So this is number 2, and it says the ammonia NH3 is used to make fertilizers for lawns and gardens is made by reacting nitrogen and hydrogen according to the following reaction. So this reaction right here, we need to balance. So how are we going to balance this guy? Okay, good. So a 2 here. And then is there anything else I need to do? Boom. Good job. All right. So now I'm going to reiterate and kind of go over the steps again. Okay. So I'm going to put them up here. So I changed them up a little bit to make it easier. So the first step is to start with the given. That's the same. Second step is to cancel units diagonally. Third step is to end with need on top, stop. And then fourth, you're going to fill in the holes. Fifth, multiply across. Divide by bottom. And then last but not least, we're going to look at our units. Okay, so those are the same rules. I think I added number 4 to it, but that's about it. All right, so let's start. So rule number 1, step number 1 says to start with the given. So if I'm starting with the given, let's read this question. It says, determine the mass in grams. Oops. The mass in grams of NH3 formed from 1.34 moles of nitrogen. Okay, so the first thing we got to do is determine our given and our need. All right, so our given, what is our given going to be for this problem? Good job. 1.34 moles of nitrogen. What is our need? Good. Good job. Grams of NH3. Very nicely done. All right, so step 1 says to start with the given. So we are going to start with the given. So we have 1.34 moles of N2. Draw a little bar. Now, step 2 says to cancel units diagonally. So if I have moles of N2 up here, what do I have to have in the basement? Good job. Moles of N2. All right, so now this is something newish. So now that I have moles in the basement, I have to ask myself the important question. And the important question is, are the compounds for my given and need the same? Okay, so if the answer to this question is yes, Then we're going to go to grams. If the answer is no, then we have to use the mole to mole bridge, okay? This mole to mole bridge helps us go from one compound, I cannot spell today, to another compound, okay? So when we have mole over mole, it's going to help us go from one compound to another compound. And the way we're going to get there is by using the balanced equation. All right, how we feeling? Almost there? Okay, don't worry. We're not even close. Okay. All right, so knowing that I need to go from one substance, so I need to go from N2 to NH3. Those are two separate substances. So that means I need to use the mole to mole bridge. So I'm going to go from moles of N2 to moles of NH3. Okay. So the reason I can do that is because I have the ratio built into the balanced equation. So now we're not finished because I can't stop because what I need is grams, but what I have right now is moles, so I have to keep going. So if I have moles of NH3 on the top here, then that means I have to have moles of NH3 down here. Now that I have moles, I can go to grams of NH3. I can go to grams because by knowing that I have grams over mole, I can use the magical molar mass. Okay, when we have grams over moles or moles over gram, we're going to use the molar mass. Okay, so now I got to ask myself, do I have what I need on top? I need grams of NH3 and I have grams of NH3 on top. So what do? I stop. All right, so how are we feeling about that? Good, I like to hear that. All right, so now step 4 says to fill in the holes. This is where you recognize that it's just one big puzzle, okay? So this first bracket situation we have going on, we have moles over moles, okay? Because I have moles over moles, I'm going to use the balanced equation, okay? Moles over moles, I'm going to use the balanced equation. They do, but the units cancel out, but we still need a number to go right there. So we still have blanks here that we have to fill in. You're good. You're good. Good question. Great question. So let's see. I got to use the balanced equation. So how many moles of NH3 am I going to make? So we're going to look at the balanced equation and use the coefficient to answer the number of moles. Correct. Good job. And how many moles of N2 are we going to make? So it's a little deceiving, but we're only going to have 1 mole of NH2. Okay? It is very confusing. So we have 1 mole of NH2. So we're going to have a 1 there. All right. So now that we've done this one, we can go to our next bracket. So let's look at this next group. This next one, we have grams over moles. Okay, so we have grams over mole. What can I use to find grams over mole? Good job. Molar mass, the molar mass. All right, so I'm going to find the molar mass of NH3. I'm going to do it down here. NH3, I have nitrogen and hydrogen. One nitrogen, three hydrogen. The mass of nitrogen. Do you need a periodic table? Okay. I'll drop it in the chat for you. Wrong link. Okay, look in the chat. All right, so we need to find nitrogen on the periodic table. What is the mass of nitrogen? Good job. Good job. And then I will find hydrogen for us because it's the easier one. I'll find it. 1.008. Make you do all the hard work. And then we're going to multiply, right? What do you get as the mass? What do you get for the mass? Mm-hmm. Good job. And then we're going to add them together. And what do we get as our total? Good job. That's what I got too. And our units are going to be grams per mole. All right. So now I'm going to take this number and he is going to go, or she, or they, is going to go on my grams spot. Okay. Because it's 17.031 grams per 1 mole. All right. So let's plug it in. 17.031 grams. Can you see this still, or is it tiny, or you're good? Okay. And then it's going to be per 1 mole. Yes, when it's that is a great question. When it's grams per mole, it's always going to be 1 mole. Only time it may not be 1 mole is when you have mole over mole. But if it's grams per mole, it's always going to be 1. That is a great question. It Yes, exactly correct. It would be. So if you had mole on top, it would still be 1 mole and then like 17.01 grams on the bottom. So that's right. So even if it's flipped, it's still going to be 1 mole. Good questions. All right, here we go. Now, step 5 says to multiply across and divide by the bottom. So we're going to multiply across and then divide by the bottom. All right, so what does that mean? We're going to stay in our lane. Always stay in your lane. So this is our top lane. This is our top lane. So we're going to multiply all these guys. And then for the bottom lane, we're going to multiply these guys. Okay. So let's see what we get. When we multiply across the top, I got 1.34 times 2 times 17.031. Good job. Me too. Look at us crushing it on this. What day of the week is it? Wednesday? Is it Wednesday? I don't know. Good job. It doesn't feel like a Wednesday. I don't know why. Maybe because of the rain. And now we are going to multiply across the bottom. Lucky for us, it's 1 times 1, which is 1. So anything divided by 1 is going to be itself. All right, we're not finished because we need to do some rounding, okay? So if I'm looking at my original question says I have 1.34 moles. So that 1.34 is going to tell me exactly how many digits I need. So 1.34 has 3 digits. So that means my answer needs to have 3 digits. I'm going to look at the 4 to see what happens to the 6. And that gives me the final answer of 45.6. Now I need some units, right? So I'm going to have my moles cancel out with my moles. My moles of NH3 cancel out with moles of NH3. And I'm left with grams of NH3, which is great because that's what I needed. Boom. It was a lot of work, but you did it. You did it. All right, let's try this next one. Any questions? Okay, let's look at this one. All right, what is the mass in grams? I always like to underline as I'm working and box as I'm working because then I don't have to do it twice. Read it twice. What is the mass in grams of hydrogen required to react with 1.34 moles of nitrogen? Okay, I'm going to rewrite our balanced equation right here. So I had N2 plus H2 yield H3. Okay, so what is the mass in grams of hydrogen required to react with 1.34 moles of nitrogen? All right, so first thing we got to do is figure out our given and our need. What's our given? Good job. Nitrogen. And our need is good grams of hydrogen. All right. So rule number 1 says to start with what we've been given. So we have 1.34 moles of N2. All right. Since I have moles of N2 at the top, what do I have to have in the basement? Good job. Okay, this is where we stop and ask the question. Now that I have moles in the basement, This is when we stop and ask the question, is what I need and what I'm given, are they the same compound? What's our answer for this? So what I need is right here, right? So I need H2, but what I've been given is N2. So since those are two different compounds, then I have to use my beautiful mole to mole bridge, right? So I'm gonna have to have moles, oops, moles, good job, of what I need, which is H2. All right. Now, we're not quite finished yet. Good point. So now that I have moles of H2 at the top, are you talking about the grams of H2? Yes. So we're not quite there yet because now I have moles at the top. So I have to keep going, right? So I have moles of H2 at the top on this bracket, which means I need moles of H2 in the basement next door. That's going to lead me to be able to have grams of H2 at the top. And I can do this because grams over mole can be found using the molar mass. Okay. So now I ask myself, do I have what I need on top? Well, I have grams of H2 at the top, and that's what I need, so I can stop. So the next question is, how am I going to fill in all these holes? Hmm. This one right here, moles over mole. What am I going to use to fill in that one? Good job. The balanced equation. All right. So how many moles of H2 do I have? Good job. And how many moles of N2 do I have? Great job. All right. We just did that one. Now let's move to the second one. I have grams over mole, and you told me this earlier, but tell me again, how am I going to complete this missing bracket? Good job. All right. So we need to find the molar mass of H2. This one's pretty easy, right? Oh, 8. What's the mass of hydrogen again? I think so. Good job. I thought it was 8. Nice. So we just have to multiply that times 2. Good job. 2.016. 6. And how many moles on the bottom? I have grams. It's tough, but remember when I have grams on top or grams involved in the bracket, it's going to be 1. So whenever you think molar mass, you're going to have 1 mole. All right, now that I have filled in all the holes, let's do some multiplication. So I have 1.34, staying in my lane. It's 1.34 times 3 times 2.016. I got 8.10432. And then my basement's going to be 1 because it's 1 times 1. Did you get 8.10432? Awesome. Yes. 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 It is 8.10 grams of H2. That is exactly correct. Good job. Look at you go. Look at you go. Proud of you. All right, here we go. Let's do this next one. I don't have very much room for this one. Okay. All right. How many moles of nitrogen? So we can go ahead and box that guy. How many moles of nitrogen are required to produce 11.7 moles of NH3? All right, what's my first step going to be? Well, my first unofficial step. Good job. What's my given? Good. Oops. Good. Oops, I did this wrong. It's moles. That's my fault. NH3. There we go. All right, what do I do now? Good job. Good. Good. Good job. This is the point. Since you have moles in the basement, you ask yourself, yep, are they the same compound? Okay, so what you've been given, I think you wrote, yes, I think you wrote N2 for your given, and it should be NH3. You might not have done that, but I did that, so I don't know if you did that too. I had N2 for my given instead of NH3. Mm-hmm. Moles of NH3. Mm-hmm. Correct. So what's going to go on top? Good job. Good. Okay. Stop and ask yourself. All right. Am I finished? Do I have what I need on top? Okay. What do we need? Isn't that crazy? Right? We need moles of N2 and we have moles of N2. So guess what we get to do? Stop. Isn't that weird? It throws you off when they're too easy, right? Right? So now we have moles over moles, and we got to fill in our holes. So we have moles over moles. And what am I going to use to fill in a mole over mole hole? Good job. Hmm. Good job. All right. So now what do I do? Yeah, good job. Yay! Yes, yes. Because our moles of NH3 canceled out and we were left with moles of N2. Boom. You crushed that. Ah, no, that was pretty good. But no, give yourself some credit. Give yourself some credit. All right. Let's see what's next. Oh, do I have another page? I do. Uh, this way. All right. I'm going to try to make it again. Let's see. There we go. Tell me when it's large enough. Okay. And yes, there really is a car honking outside of my door incessantly, such as my apartment complex. All right, here we go. We have how many moles of nitrogen? So we need moles of nitrogen are required to produce 11.7 grams of NH3. I'm going to write our equation up here again just for safekeeping. N2 plus H2 yields 2 NH3. All right, what's my first unofficial step? Good. Yes, just crush it, why don't you? Keep it going. Good. What's going to go on top? So close. We have grams down here. So whenever I have grams in here, what do I have to have at the top? I am going to have moles, but it's going to be moles of who? So if I have grams and mole, we have to have the same compound. So I can't have grams of NH3 under moles of NH2 because I wouldn't be able to find how many grams of NH3 there are in 1 mole of N2. It just wouldn't work out that way. So if I have grams involved, I have to have moles of the same compound on top or underneath. So if I have grams of NH3, that means I'm going to need moles of NH3. Let, let it sit there for a second. Hmm. That keeps you able to use the molar mass, because it's not like we're finding molar mass of different compounds. It's one compound. Okay. So let's keep going. Let's keep going. What comes next? Mhm. Correct. The moles of the need. Why do I need to do that? Yes. And I can do this because given my given and my need are two different compounds. So that's why I need to transition using the mole to mole bridge. Mole bridge. Okay? Am I finished? So what do I need? Yes, I am going to use the balanced equation. So I can stop right here, right? Do I need to keep going to another bracket or can I stop? Good job. All right, so let's start filling in these holes. So you picked this mole over mole to fill in first, right? Okay, so what goes where? Mm-hmm. Good job. And where did you get these numbers from? Good job. All right, now I have a mole over gram. So what am I going to use to fill this in? Good job. The molar mass of NH3. Nitrogen is what, 14.007, I think. Yeah. Yeah. 031. Good job. And how many moles? Good job. Good one. That was good. It is one. Good job. Now what do I do, Olivia? Good job. Mm-hmm. Good job. Right. Now I'm going to divide. What did you get? Okay. So what is that going to round to? I'm going to look back at my problem. Good job. And my units? Nicely done. Boom. Bam. Pew, 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 pew. Pew, 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 pew. Pew, pew. Crushed it. Yay! I love to hear that. That makes my heart smile. Yay. Okay, let's do one more, but we're gonna do a different one that has, I think this one will have one more step, so I don't want you to leave without doing one more of these. So um let's do A from number 3. Okay. So given the following equation, we have potassium plus chlorine yields potassium chloride. All right, so first we need to build this equation, right? So I have potassium, which is what? Good. Is he one of our diatomic elements, or can he just ride alone? I know it's hard to remember this. But generally speaking, group 7, nitrogen, oxygen, will be your diatomic, so potassium's not going to be one of those. 17, my bad. So it's not going to be one, so it'll be good. Group 17, they are diatomic. So group 17, it actually makes a 7. So if you're looking at your periodic table, from nitrogen over to fluorine, and then down to chlorine, bromine, and iodine. So those, oh, there's one more somewhere. Acetane. These 7 will make diatomic elements. So when you see them alone, you have to make 2 of them. They come in pairs. So like chlorine, this next guy, he's going to be Cl2. Okay. Cl2. And then we're going to yield, what do you think this is? Potassium chloride. What do you think it's going to look like? Yep. So we have potassium chloride. This is a +1 ion. This is a -1 ion. We do the drop, lock, cross drop, and lock it. And we end up with regular old KCl. So, KCl. So let's balance this guy. How are we going to balance him? Good. Boom. Crushed it. Absolutely crushed it. All right, now the fun part. How many grams of potassium chloride are produced from 3.50 grams of potassium? All right, so we have grams of potassium chloride are produced from 3.50 grams of potassium. All right, what do I do first? Good job. Given, need, what you're given. Good job. Good job. Now what do I do? Good job. Now what? Good. What's going to go on top? So close. So close, friends. So close. Okay. Since we have grams involved, we're going to have moles of the same substance on top. Okay. And the reason why we do that is because we need to be able to find the molar mass. Boom. Okay. So whenever we have grams involved, we have to, yep, have to have moles of the same compound. All right. Now what do I do? Mm-hmm. Good job. Good. What is my need? Good job. All right. Am I finished? Good. Good. I have to keep going. So what goes in the basement? So remember, I can do this bracket right here. This middle bracket is critical. Oops, that's the wrong color. This middle bracket is critical because this is how I can change substances, my mole to mole. Yes, you always have to have mole to mole in order to change substances. Sometimes you won't need it in your problem, sometimes you will, but if your need and your want um, are not the same compound, then you have to have the mole to mole bridge. So our need was KCl, but our given was K. So since those are two separate things, we had to have the mole to mole bridge because it'll get us from one compound to another. Okay. All right. So what are we cooking with? What's got to go in the basement? Good. And what can finally go on top? Good job. Grams of KCl. All right. So now we need to fill in our holes. So this first one, I have grams and moles. So what am I going to use? Good job. What is the molar mass of potassium? Good. And how many moles? Close. We have grams involved. So when it's grams involved, it's always going to be what? Potassium. So what is how many moles am I going to have? this blank up here. So it's going to be 1. So the reason why it's 1 is because we have the molar mass. And the molar mass is so many, so it's 39.098 grams in 1 mole. That's next. That's next. So you're right. We do have 2 moles of K in the next bracket. And how many moles of potassium chloride? Good. All right. Now I have grams over mole again. So what am I going to use? Good. So let's find the molar mass of KCl. What'd you get? Beautiful. All right. And how many moles? I have grams involved. Good. Boom. Now what do I do? Good job. Mm. Then we got to multiply across the bottom. And then we divide. That means, what'd you get as your final answer? Take your time. That is exactly correct. Boom. And that is the hardest the problems will be. So I honestly won't give that to you on the test because I think that's excessive and not the point of this unit. So I probably will give them to you. I don't see why you would need to write them for this unit. You guys already did that. So no. Yeah, I think you could knock this out the park. I think so. I think so. Good job. Well, I'm going to stop our little recording. Stop it. Let me see if I know what I'm doing. Oops, wrong button. Stop that. And then let me stop this one.